The Nancy Grace Roman Space Telescope, formerly known as the Wide Field Infrared Survey Telescope, is a future infrared space observatory developed by NASA that will revolutionize the hunt for exoplanets and perhaps detect extraterrestrial civilizations. Named after NASA's first chief astronomer, Nancy Grace Roman, who was a pioneering scientist and a key figure in the development of the Hubble Space Telescope. The mission is set to launch in 2027 on a Falcon Heavy rocket. It will be situated at Lagrange Point 2, a stable gravitational point between Earth and the Sun located around 1 million miles away. This vantage point will allow the telescope to observe the universe with unprecedented clarity and detail. Combined with a 2.5-meter primary mirror, it will provide astronomers with a panoramic vista 200 times larger than Hubble's infrared view, and do it faster. The primary mission of the Nancy Grace Roman Space Telescope is to complete the statistical census of planetary systems in the galaxy by using its wide field of view to search for planets and investigate the physics of distant stars, providing valuable insights into the diversity of planetary systems beyond our own. Other key objectives of the Nancy Grace Roman Space Telescope include the investigation of dark energy, the mysterious force driving the expansion of the universe. By studying the cosmic microwave background and the large-scale structure of the universe, the telescope aims to shed light on the nature of dark energy and its impact on the universe's evolution. The Roman Space Telescope will also be used to observe galaxies, supernovas, black holes, and other objects of interest. It will also be used to investigate the consistency of general relativity and the curvature of space-time. The telescope will carry two instruments. The Wide Field Instrument is a 300.8 megapixel camera, providing multiband visible to near-infrared imaging using one wideband and 6 narrowband filters, providing a sharpness of images comparable to that achieved by the Hubble Space Telescope over a 0.28 square degree field of view, 100 times larger than imaging cameras on the Hubble. The coronagraphic instrument is a high-contrast coronagraph covering shorter wavelengths. It uses dual deformable mirror starlight suppression technology. It is intended to achieve a part per billion suppression of starlight to enable the detection and spectroscopy of planets with a visual separation of as little as 0.15 arcseconds from their host stars. The CGI is intended as a technology demonstrator for an exoplanet imaging instrument on a future large space-based observatory. If you managed to watch this far, you should probably hit subscribe. There's a little button there in the bottom right corner. Go ahead and click it. The Roman Space Telescope will have a field of view at least 100 times greater than that of the Hubble, providing a panorama 200 times the size of Hubble's infrared view. This wide field of view will allow the Roman Space Telescope to conduct the first wide-field maps of the universe at space-based resolution, enabling it to survey billions of galaxies and capture the light of stellar explosions in its quest to solve the mystery of the universe's expansion. Additionally, the Roman Space Telescope will have the sensitivity and resolution comparable to Hubble, but with a field of view 100 times larger, combining excellent image quality with survey power. Furthermore, while the Hubble and James Webb Space Telescopes are optimized for studying astronomical objects in depth, the Roman Space Telescope will be able to capture an unprecedented number of galaxies in its field of view, making it suitable for studying a wide range of astrophysical and planetary science topics. The mission's observations of galaxies and supernovas will tell us a lot about the history and future of the universe. The Roman Space Telescope will be a significant tool for the science community, as all Roman data will be publicly available immediately after processing and delivery to the archive, and scientists around the world will be able to use the observatory to study the cosmos in their own way, from the nearest exoplanets out to clusters of distant galaxies.